and really the notes for today are pretty basic. We are just going to start with learning the rule for derivative of log functions. Okay, and it's just a rule. The derivative of natural log of x is simply 1 over x. That's it. And we're not deriving it. There's nothing to do or know about it. You just have to memorize that the derivative of natural log of x is 1 over x. Now, the question that you guys should be thinking about is, okay, well, what if it's not just x? What if it's more than x? What if we want to find the derivative, say, of, I don't know, natural log of x squared plus 3? Or maybe we want to find the derivative of the natural log of the square root of x plus 5. I don't know. So some more involved log. Well, hopefully you guys are already thinking about this. If it's more involved, it's going to be what we call the chain rule version of natural log. So I'm going to say, what if we take the derivative of the natural log of something? I'm going to call it u, but that u means something that's more than just x, maybe x squared plus 3. Well, the chain rule would say it's like the derivative of natural log of x in that it's 1 over x. Well, in this case, it wasn't an x, it was an x squared plus 3, right? Or in this case, it was a u. So yeah, the derivative of natural log of u is 1 over u, but then the chain rule would say multiply by the derivative of the inside, so we should multiply this by whatever the derivative of u is. And then we tend to write, the shortcut version. The derivative of natural log of u is just going to be u prime over u. So if I'm looking at this first one, right, if that's my original function, then the derivative of that is, well, x squared plus 3, all of this is u, so u prime would be 2x, all over u, which was the parenthesis, so all over x squared plus 3. And that's it. U prime over u. Now, I know some of you overachievers are probably thinking, oh look, maybe I should simplify. Maybe I should cancel out the x squared and the x. Of course, you and I are both thinking that not only are you overachievers, but you're murderers because you're killing puppies when you do that, right? You can't cancel those out, so you just leave it. Okay, now, you got to be thinking to yourself, well, there's got to be more to it than just that, and you would be right. So the next thing I want you to keep in mind is sometimes it's useful to use log properties before differentiating. So what are log properties? Well, that's part of what your pre-calculus and your Algebra 2 material that you're supposed to remember, but since we're going to use them right away today, let's do just a very quick crash course. You may remember from back in the day that if you have the log, it doesn't matter what the base of something, I'll say log of a, it might be log base 3, log base 10, log base e, it does not matter, and you add it to another log. So I'll say log base A plus log base B. If you want, you can combine those two logs into one log, and it becomes log of A times B. I hope that at least looks a little bit familiar. And then hopefully that makes you think of the next one that says, what if you subtract, say, log A minus log B? And that would be log of A over B. And then the third one, and I'll write this one as a natural log. The third one says, let's say you have the natural log of x squared, right? Well, what this property says is if you want to, you can take that exponent down in front. So that could be written as 2 times the natural log of x. Okay, so those are the log properties from your Algebra 2 days. And note, remember what we said up here, that sometimes it's useful to use those before you take the derivative. And here's what I mean by that. Remember our example up here of natural log of square root of x plus 5? What if, before we do the derivative, what if we do a log property, right? Well, I know that square root means exponent of 1/2, right? So really that's natural log to the 1/2. Well, according to that third log property, if I want, I can move that exponent down in front, and what I actually have is 1/2 natural log of x plus 5. Now, I have not done the derivative yet. All I'm doing is manipulating this, right? So now, if I want to do the derivative, I can say leave the constant alone, and then if I do the derivative of my natural log of u, it's going to be u prime over u. So let's see, u prime, derivative of x plus 5, is just 1 over itself, so over u is x plus 5, right? So basically the derivative is just 1 over 2 times x plus 5. Now you might be saying, well, gosh, that was a bunch of steps. I mean, hopefully you're not even thinking of this one up here as a step because it was so basic. But what if I hadn't done that? What if I hadn't moved that 1/2 out in front? How ugly would this derivative have been? Well, remember I started with natural log of the square root of x plus 5. So what if I think of this whole square root as my u, right? So then if I do my u prime over u, in order to do u prime, I would have had to do a chain rule on this, right? The derivative of this would be 1/2 x plus 5 to the negative 1/2, and then you say times the derivative of the inside, so times 1. So that's my u prime, and then all over u, so it would have been all over square root of x plus 5. So it's not impossible, but look how much uglier this is, how many more places for mistake than this. Okay, so definitely use the log properties to make it seem a little more basic before you do the derivative. And basically that right there is what the majority of the homework looks like, the idea of using a quick log property and then applying your rule. Okay, so there's one more thing that comes up, and that is, look what I have here. It says logarithmic differentiation is useful on some involved functions involving products or quotients. In other words, if I just want to take the derivative of y equals this big mess, notice it's not even a log problem, right? It's just a big old giant fraction. Well, I've got rules that I can use to do that derivative. If I want to do the derivative of this, first of all, I would say, well, hey, it's a quotient, right? So I'd have to do a quotient rule. And think about it, if this is the numerator and this is the denominator, when I do my quotient rule, just to take the derivative of the top, wouldn't I have to do a product rule? Because just on the top, don't you have x times this square root? So I'd have to do a product rule there. As a part of that product rule, in order to do the derivative of the square root, wouldn't I have to do a chain rule? And then in the denominator, when I do the derivative of the denominator, aren't I going to have to do a chain rule? So this is going to have quotient rule, product rule, and 2 chain rules involved. And then think about the simplifying. Okay, well, here's kind of a fancy little technique we can do. What if, before I do the derivative of this, what if I turn it into a logarithm? In other words, what if I take the log of both sides? So I'm not doing any calculus yet. I'm just going to take the log of both sides. So I'm going to say the natural log of y equals the natural log of this whole big mess, right? The natural log of x square root of x plus 2 all over x minus 3 to the 4th, right? So I just took the log of both sides. And what if, before I do the derivative, what if I use the log properties, right? Notice it's a fraction, so I can do subtraction for that. Notice the numerator is a product, so I could do addition for that. So here's what I'm going to do. I'm going to stretch this out. I'm going to turn this into, first of all, it's going to be, I'm going to write in more steps than I would normally write in since this is day 1, okay? So first of all, I'm going to write it as natural log of x times the square root of x plus 2, so that's the top, minus natural log of the bottom, right? So I used that second log property. And so now I'm going to do 2 properties at once. I'm going to do the first property, right, on this one, turn that into addition. And at the same time, I'm going to do that third property, and that square root, I'm going to bring the 1/2 out in front, and then that 4 I'm going to bring out in front. So here's what I have. I've got the natural log of x plus square root, so bring out the 1/2. Again, I'm not doing the derivative yet. I'm just using log properties. So 1/2 natural log of x plus 2 minus, and then over here I'm going to bring that 4 down in front, so 4 natural log of x minus 3. So that's what I have on the right, and this is all supposed to equal natural log of y. Okay? So I've turned this into a log problem. So now when I'm ready to take my derivative, come over here, I'm going to say, well, what's the natural log of, what's the derivative of natural log of y? Well, look up here. Natural log of u derivative is u prime over u. So natural log of y derivative is y prime over y. And then on the right side, derivative of natural log of x is 1 over x, right? Derivative of this next term, so 1/2, I can leave that alone. In order to do the derivative of this natural log, I'm going to do a u prime over u, so that's going to be 1 over x plus 2 minus, 4 is a constant, leave it alone. So in order to do the derivative of this log, I could do a u prime over u, so wouldn't that just be 1 over x minus 3? So that was a much easier derivative with all those logs than if I had to do that big old quotient rule and product rule and chain rule business. So, have I found the derivative? Well, if I want to solve for y prime, how do I get rid of that y? Wouldn't I just multiply? So I'm going to say y prime equals, multiply by y times all of this, right? So y times 1 over x plus 1 over 2 times x plus 2 minus 4 over x minus 3. And I'll just leave it like that. So it's still kind of ugly, but getting there wasn't bad at all. Okay, so that's it. It's just kind of the one rule, taking derivative of natural log, you know, with kind of that extended chain rule. Keep in mind what I had told you guys earlier from the calendar. Your assignment is accurate on the calendar. So you've got the whole class time to either work through some of that prerequisite stuff. Maybe you guys should, you know, work together, take some time to see how much of that you can go through, and then get started on this 5.1 homework. All right, good luck with that.